Good afternoon and welcome to the Q&A session 19 from the playlist of IIT-JEE Advanced Physics. The topic is the calculation of force due to an electric field, and based on this topic I have one question which was asked in the IIT-JEE examination in the year 2010. So here the question is, two hemispherical shells are held together by an external force as shown in this figure. So these are the two hemispherical shells which are held together by an external force. So these two hemispherical shells are in contact with each other due to the application of this external force, and this shell has got uniform surface charge density sigma and has a radius of r. So the external force is proportional to, so we have been given here 4 options, and we have to find the correct option. Now we know that the energy stored per unit volume of a dielectric medium in a electric field region U is equal to 1 by 2 epsilon E square, where epsilon is the permittivity of a medium and this epsilon is equal to epsilon naught into epsilon r. So here epsilon naught is the permittivity of free space and epsilon r is the relative permittivity. So here if I am considering the medium to be free space, then this formula will become equal to 1 by 2 epsilon naught E square. Now we also know that the energy stored per unit volume is equal to pressure. So the pressure is equal to 1 by 2 epsilon naught E square, and pressure is equal to force upon area. So this is equal to 1 by 2 epsilon naught E square. So from here we can find the electrostatic force. Let us say this is Fe. So this is equal to 1 by 2 epsilon naught E square into A. That is the electrostatic force experienced by these two hemispherical shells due to the uniform distribution of charge which is residing on the surface of it is equal to 1 by 2 epsilon naught E square into A. Now now here we have to find the value of E, that is the intensity of electric field. So we will be using the Gauss law. As per the Gauss law, the EA cos theta, this is equal to Q upon epsilon naught, and here theta is the angle between the direction of the electric field and the normal to the surface. So here theta is equal to 0. So cos 0 will be equal to 1. And so the intensity of electric field on at any point on the surface of this shell, this will be equal to E 4 pi r square, and Q here is the net charge enclosed by this surface. So this will be equal to sigma into 4 pi r square and divided by epsilon naught. So from here the value of E, this is equal to sigma upon epsilon naught. So if I substitute this value in this equation, then I will get the value of the electrostatic force on these two hemispherical shells. This will be equal to E is equal to sigma upon epsilon. So this will be equal to sigma square upon epsilon naught whole square into A. Now here A is what? This is the projected area, or you can say the area which is of these two hemispherical shells which are in contact with each other. So this is equal to 1 by 2 into, this will be equal to sigma square, A will be equal to pi r square and this will be equal to, this will get cancelled, epsilon naught. So from here, the electrostatic force, which is denoted here as Fe, this will be equal to 1 by 2. This will be equal to pi r square. This is sigma square r square, and this is equal to 1 by 2 sigma, sorry, this is equal to how, sorry, this is sigma square, and this is pi r square divided by epsilon naught. So this is sigma square r square into pi divided by epsilon naught. Now this is the electrostatic force which is being experienced by these two hemispherical shells, and the direction of this electrostatic force will be outward. So in order to keep these two hemispherical shells together, I will be exerting a force F, which should be equal to this value. So the external force, say F, this will be equal to 1 by 2 into pi into sigma square r square upon epsilon naught, or we can say that F will be proportional to, here pi is constant, epsilon naught is constant, and 2 is constant, this will be proportional to sigma square r square. So the correct option here will be A. So thank you very much for joining the session. In the next session, I will be coming up with a different type of a question from the chapter of electric charges in field. So till then, have a nice day. Bye.